Hi, good morning and good afternoon, everyone. Thanks for joining us today. December 11th, it's our last webinar for this year, 2018. It's great to have you with us. My name is Jean-Jérôme, and I'll be looking after you for the next hour or so. The topic for today is all around failover and the processes for it and how to manage failover and automate it for MySQL, MariaDB, and Postgres. I'm with the Several Nines team, and I'll be looking after you for the next hour or so. If you have any questions during this webinar, feel free to ask them by using the question section of your control panel, and you can do that at any moment. Of course, or use the chat box also to reach out to us, whether it's on the content that we're going through or whether you have some questions on the system itself, the webinar system. And you can also contact me if you want after the webinar, for more questions or to continue conversations at jj@7nines.com. And I'll be happy to look after you then, of course, also. Just before we get started, a quick introduction to Several Nines and the product that we propose, ClusterControl. We're a team that specializes in automation and management of open source databases. And we've put our experience and knowledge into a product called ClusterControl, which covers these 10 kind of key areas of database administration and automation. That range from backup management to monitoring and alerting some of the key database administration tasks, all the way through to performance management and our automated performance advisors. We'll have some insight into ClusterControl during the session also, but this is just to give you a quick overview. We have a free community edition that you can download that comes with an initial 30 days enterprise trial, which means you can use all of our commercial features during the first 30 days of installation of ClusterControl. And then it reverts into the community edition, which you can use forever. And if you want to continue using the commercial features, we have, of course, commercial versions, of course, as well that you can avail of. The product itself consists of these kind of key areas and key feature sets around the deployment, which is part of the community version, and that you can do on-premise or in the cloud. And then you've got a whole range of monitoring features, including, it's whether you want to monitor agentless via SSH or agent-based via Prometheus, which is one of our new monitoring features that we just released recently. And then on the right-hand side, you can see all of the management features that we offer also, from backup management to upgrades and patching and all the way down to performance management. And we cover and support the top 4 most popular open source databases out there, whether it's MySQL, MariaDB, MongoDB, and Postgres. Today, of course, being all about MySQL, MariaDB, and Postgres. And these are some of our customers and users who have been working with us for a number of years and that we're happy to support with ClusterControl. But for today, the topic is all around managing replication failover processes for MySQL, MariaDB, and Postgres. My colleague Christoph Schoncheck is joining us today to present. But to get us started, I wanted to ask of all of you a quick question around downtime, which is kind of course related to today's topic, and this is to ask how much downtime you've experienced yourselves in the past year, whether it's under 5 minutes, under an hour, or more. Or no downtime at all, which of course would be the ideal scenario. So it'd be great to get your feedback and see what the outcome is, and that will set the scene a little bit for today's session before we get started with the actual presentation. I'll let this run for a few seconds, just to give everyone the chance to participate, and just to remind you also that you can ask us questions at any moment by using the question section of your control panel. But for now, I'll let this run for a bit, and I'll share the results once everyone had a chance to participate. Thanks very much for providing your feedback here. I'll close this now and share the results. So that's a pretty even breakdown, a third and a third and a third, but under 1 hour, 1/3 of you, just over 4 hours for the other third, and then no downtime at all, which of course is great to hear. Christoph, any reactions to this poll before you get started?
Yeah, I mean, it's definitely nice that some of you mentioned to have like any downtime during the whole year. That's really good. But generally speaking, it's the amount of issues varies, and the environment varies, and the ability of building the highly available solution sometimes it's limited by by the business logic, by the environment. So I guess as long as we are with downtime, it's like that. As long as we are meeting the SLAs, then that's perfectly fine. Downtime is not bad. It's just a matter of whether we met the requirements or not. That's what actually matters.
Cool, makes sense. Thanks, Christoph, and thanks everyone for your participation in this poll. And with that, I'll hand over to you, Christoph, for today's presentation.
Okay, thank you, JJ. So good morning, good afternoon, everyone. My name is Krzysztof Książek, and as JJ said, today we'll be talking about failover processes in MySQL, MariaDB, and PostgreSQL. So first of all, a bit of agenda. So I'll start with talking about some basics, some introduction to failovers, and what the failover is all about. So in MySQL and MariaDB, and how it looks like in PostgreSQL. Then I'll touch base on the question, whether to automate or not, because that's always it's not always the clear call between those two. Then I'll talk about the failover process and how it works across the whole high availability stack. I'll touch a bit about different difficult problems and that are kind of like related to the failover, and then may impact the failover itself and the environment while it's happening. And finally, I'll show you how ClusterControl can help you handle both manual, assisted failovers and automated failovers. So first, let's start with some basics. So what is the failover, when it happens, how it happens? So a short definition. So the failover, so first of all, the switchover. So the switchover is a process of switching a master role to another server, to a process of the slave promotion. So in short, we're talking today about replication setups, right? So in every replication setup, you have like one point of entry, which is a master, active server, however you call it. So you direct your writes towards this particular host. And then you may, if you want, you may scale the reads across the remaining slaves or standby servers. So sometimes you have to perform a switch, like let's say you're doing some rolling upgrades, some maintenance, whatnot. In that case, you basically perform a switch over and move this master role from one host to another. A failover basically is the process of switching a master role to another server through a process of slave promotion, which means it's basically the same thing. The difference is that if we are talking about the failover, we kind of expect that old master is either not available or its availability is limited to some point. So basically, when we are doing a switchover, we kind of have a control over all of the aspects. So we can stop the traffic, we can pause the writes, for example, make sure that this slaves are caught up fully with the master, and then perform a switchover. In failover, we kind of can expect that things might be incorrect. So the slaves might be lagging, the slaves might not get all of the data because, let's say, the master wasn't able to send, it stored the data in binary logs, for example, but it didn't send it to the slave, because let's say we are talking about like asynchronous replication. So basically, failover is like a worst scenario for the switchover, because we cannot expect that everything is smooth and and in sync. So, and today we'll be talking about the failover. So basically, as I said, in replication setups, you have this like entry point for your writes. So being the master or active server. And if this master becomes unavailable for whatever reason, then, well, typically we have to perform a failover, right? That's because if there's no node to handle the writes, then obviously, I mean, depends on the application, but I would say the majority of the applications will not be able to work correctly, or if they were prepared, if they had some sort of like read-only mode, then their operations would be pretty much limited and to just like hold until the problem is fixed. So so basically, if there's no master, then the database cluster is not operational, and the application is most likely not operational also. So this is quite important case, and that's why the failover has to be performed. So what is important, and you may find across this presentation that I'll be kind of like reiterating over some of the points, and that's just only because those points are very, very important to keep in mind. And this one is one of those points. So it is important that you should verify the master connectivity from the point of the slaves, or from another hosts on another location, just so that you avoid the case in which your monitoring server is, for example, cut off from the network, or it does not have an access to the master for whatever reason, while the slaves are still working happily and replicating. So the failover should be should be performed only when you just verify that, okay, the functionality is indeed affected. So the slaves are not replicating, or your writes are not hitting the master or whatnot. So this is something you need to keep in mind. So how does failover look like in MySQL? And here I'm talking, about, generally speaking, for MySQL, I'll be talking about the GTID replication, because let's say that this is, this is quite popular nowadays, and it's also pretty nice to to actually manage it. It's much easier to manage GTID replication. So the master crashes, and obviously you end up with some slaves, right? One or more. The first step, you need to verify, whether the master is indeed not reachable. And then you need to decide, which slave is most up to date, which one has the most up to date data set and receive the most transactions from the master, and then pick it as master candidate, assuming that it also matches other requirements on which I'll be talking later today. So then you need to ensure that there are no errand transactions on this master candidate. An errand transaction, in short, is a transaction which was executed on a given slave, but it didn't come from the master. So it's not, basically does not exist on. I mean, it may come from the master, some old master or whatnot, but generally speaking, this is a transaction which exists just on the slave and not on other ones. The problem here is that when slaves are connecting to master, they ask for all the missing transactions. So if you're a slave, right, if your master candidate has some transactions which were not replicated to other slaves, and if you promote it as a master and you try to slave off other slave of it, then they will ask for this missing transaction. If this is an old transaction, then it might happen that this transaction does not exist anymore in the binary logs, which is quite probable. And basically, it just means that the replication will break. So the slaves won't be able to slave off this host. You will have to fix the problem before you can actually slave it. And this kind of like prevents the failover from happening quickly. So this is quite important to ensure that this is not something that happened. And then once you slaved off, then try to collect missing data from master as long as it is possible. Sometimes it is sometimes it's just like MySQL process which was killed. So just you can try to get some more data and verify that it's in sync. And slave remaining slaves, and then also quite important point: ensure that to the best of your abilities, that all master will not be started again. So you want to keep it down. You want to do maybe some investigation of the crash. Afterwards, you might probably want to rebuild it from the data, using the data from the new master, and set it up as a slave. But it's important that it will not start automatically. Sometimes it's tricky to do, and again, I'll talk about it later. But yeah, that's quite important. So in PostgreSQL, it's quite similar. So first of all, you have an active server, it crashed, and so you end up with some standbys. So again, first of all, you need to verify that this active server was indeed down, is indeed not reachable. Then find the most advanced standby, and then trigger the failover, right? So you trigger the failover either pgct or promote or using the trigger file. Then you can use pg-rewind to sync the slaves to the new master. Reslave them, and again, ensure that the old master will not be started. Do some investigations, and then eventually rebuild it using the data from the new master, from the new active server. So that's how it goes. And then the question is, whether we should automate or not this kind of process. And there are some pros and cons of each of the options, and I'll go over those pros and cons on the next slide. So generally speaking, as you have seen on the last two slides, there are a couple of steps that you need to perform in order to execute the failover. So you need to verify the connectivity. You need to check the find the most advanced slave or standby, check errand transactions in MySQL, run PG rewind on Postgres, and then reslave them, and then whatnot. So generally speaking, the rule is like the more complex and more steps and more complex they are, the higher chance of humans making mistakes when the administrators are going through some run book, like copy paste. So even copy paste may just fail. Or commands may be executed in wrong order or whatnot. And this is especially true when we are talking about failover, which typically happens. Which typically is quite a stressful situation, and people are pretty much rushed to make sure that the situation is handled correctly. So manual performing of the failover introduces to quite high chance of human error. The scripts and everything, like all of the steps that can maybe, except for the investigation, but it can happen like later on. All of these steps can be easily scripted and automated. And this will make all of the checks, all of the actions to be performed much faster than the human being can perform. And it's also more reliable. I mean, as long as your environment stays the same, and as long as your scripts are tested against this environment, and as long as you won't modify your scripts, generally speaking, this should work. The thing is that scripts are, they are not that smart, right? I mean, you can put some logic in the program, in the script, to handle some cases, but you cannot really put enough logic to cover like all of these cases that may happen. And humans are way more flexible and better in handling, unexpected and predictable situations. So it is quite a question whether we should perform. I mean, whether we should do the automated failover or not. So as I said, let's go through some pros and cons. So definitely on the pro side of automating the failover is that the reaction time is way faster, it's way lower. So I mean, with script, it's just like, we're talking about seconds. So the script needs to detect the problem. So probably it will take a couple of seconds because, you don't want to react on the first alert, because it might be, some transient issue, which will be solved like on its own. So you want to, allow a couple of failures to show up like for a couple of seconds. And then you also need to perform more of those actions, right? So you just, I would say, we're talking about 10, 20, 30 seconds maybe to perform the failover. For humans, it's typically, I would say, like in minutes, in minutes range. So we're talking about waking up, getting out of the bed. We are talking about getting to your laptop, connecting to your VPN, figuring out what the heck just happened. Everything is what's going on, what's down, what's up, what's the situation, and then just manually perform the failover and go through all of the steps. So here we're talking about 20, 30 minutes. So just like an order of magnitude slower for the human reaction. And also automated failover gives you like higher reliability for typical situations. So that's the thing, it's just, again, this 80-20 rule, right? So like in 80% of the situations that will work just fine. And the problem is with those non-typical situations. So also when configured correctly, you can try to improve the logic. You can try to add all the new cases that you experience to be handled by the software, as long as you maintain the software, of course. But you can augment it, you can improve it, you can try to improve the number of cases that the automated failover can handle. And you can also, modify the logics through some external scripts or some actions that I'll be also talking about later. So you have some control and you can improve the reliability. Of course, also it was quite important human factor. So the automated failover kind of reduced the on-call burnout. I mean, first of all, obviously, when the failover happens and it's handled automatically, your on-call staff will be paged. That's no way to go around it. But what's important that when you get the page, you wake up, you try to figure out what's going on, and then you get another page that failover happened. And this is already better situation than okay, master is dead. I need to rush and figure out what's going on and take some actions because we are losing money and whatnot. So it already relieves your staff to some extent that it's not. They have to investigate what happened, but they don't have to rush for it. And that's also because most of the time the systems will be up and running, on one of the slaves will be promoted. So it's just a matter of figuring out what happened and maybe do some cleanup. But there are also some cons, right, of the automated failover. So as I stated earlier, the scripts will have always like limited situation awareness. They will not be able to understand the whole large picture. So that's just it. They cannot really understand how the whole situation looks like. They can do whatever they were told to check, but that's about it. Humans can definitely do it much better. Decisions that are made by the scripts are not always correct. Yes, that's again. This is because again, there's those 80-20% rule. So 80% of the cases they will be covered just fine. For 20% of the cases, well, the reaction might not be appropriate to what actually happened. Of course, if you are working with this kind of automated software, you have to test it. You have to make sure that, you know, after every change in your environment or every new release in the of the software, you have to verify that actually it works correctly and there was no regressions, no nothing. And of course, if it is your script, then it has to be maintained. So as you can see, the main differentiating factor is just the reaction time and the lack of the situation awareness. So the humans are slower, but they understand more. Scripts are much faster, but they are not that smart, really. So automated failover will be faster, but may take actions that user wouldn't, based on the given situation. The thing is that, you know, you can try to improve the logic, especially if you're maintaining this your own software for that. Or you can, you know, use some external safety features like whitelist, blacklist, to minimize the chance for some incorrect behavior to show up. You know, to some of the tools that are on the market can also, you know, improve their own, you know, visibility through utilizing multiple hosts, to verify the state of the replication topology, you know, through the slaves, or through the proxies. Some of the tools on the market can utilize like clustering protocols like Raft or Paxos to detect and handle better network splits. The thing is that, you know, you just cannot really expect automated failover to cover like 100% of the cases correctly. This is not possible at all. I mean, majority of the cases, yes, but not 100%. What you can also do actually is you can perform like an assisted failover. So you just go, you verify what is going on, and then instead of like doing some things manually, just click the button. It has its, again, pros and cons, kind of like pros and cons of both worlds kind of like came together. So it's not perfect, but might help to actually, you know, ensure that, okay, I see that I can safely execute automated failover, so I can do it. But of course, then you trade your time to perform the action for better reliability of what happened. So understanding the failover process. So we kind of discussed some of the, you know, how things look like when we are, you know, performing the failover. What are the problems? And now let's just talk a little bit more about different aspects that are pretty much critical for the whole failover process. So first of all, and again, as I said, I'll be reiterating over some points. Ensure that master is indeed down. And this is so much important that, you know, you just have to keep in mind all the time. You have to know that the master is indeed down before you perform, or actually probably you won't be able to know it by like for sure, like on all of the cases, but at least do whatever you can to verify that. You never want to run two writable masters at the same time, which is pretty kind of like obvious, right? If you have two writers, I mean, if your application can write two masters, and then most likely your replication will, I mean, the data will not be replicated correctly between them, and basically you have, you know, some sort of like data drift, and then that will be problem to actually match these data sets later on. I mean, it's doable, but it will take time. So ideally, you would implement some sort of stone it should or the other node in the head protocol process, just to make sure that you have a trigger to kill the node. So the master is not reachable, maybe, but maybe you are able to, I don't know, you know, just pull the plug or just shut down it by some other means. And as I said, you know, when you're like trying to detect this master's availability, work with multiple sources, like check the slaves. If the slaves are replicating, then it means that master is up, right? It still might be a problem because it still might not be reachable from the application, which is kind of bad because the write still cannot go there. But at least you know that, and you can take some maybe some actions maybe around, right? Maybe if your slaves can connect to your master, then maybe you and get the data from it. Maybe you can SSH to your master through your slave, and then let's say shut it down before you perform a failover. So so you need to check that, and just use all of the options to make sure that it's stopped correctly. Pick the correct slave as the master candidate. It's also pretty much critical because obviously you want to use the most advanced slave to avoid data loss, but it's also not always the same. Not always the most advanced slave, because sometimes we are talking about different versions. We are talking about different hardware and whatnot. So again, you have to balance here and make sure that the most advanced slave which actually can work as the master. Again, as I said, check for run transactions in GTID setup, because this is quite. I mean, you don't want to be in a situation when you perform a failover, but then you find that all of the remaining slaves cannot really slave of the old master because of the run transactions. And you want to try and reach the master, right, to see if they're non-replicated binary log events. Because now, if the master is not available, it doesn't mean that you cannot SSH there. Sometimes it's just that the process is down or whatnot, but you still can get there and, let's say, maybe extract binary logs and extract and then verify that your slave has all of the data. And again, it's all about the thing is that you cannot, for asynchronous replication, you cannot expect the slave to have all of the data, right? It might happen that it's just lagging or it did not get some transactions. Like for semi-synchronous slave or for PostgreSQL, even for synchronous slaves, it's slightly better, right? But then trade your the assurance that slave will have the data. You trade it with performance, because semi-synchronous and synchronous slaves, they will be reduce the overall performance of the cluster because of this need to verify that the data was sent through. Whitelist and blacklist, you need to use them basically. That's a tool for you to make sure that you don't promote like any slave, as I started to say on the previous slide. You want to have like the most advanced slave, but not every slave will work. Typically you want to stay within the same data center, right, to avoid split brain scenario with two masters. So if you're, or generally speaking, for the performance reasons, if you have like active and DR data centers, you most likely don't want to just switch DR just because one node went unavailable in the active data center. You want to stay within the same versions. Maybe you have some slave or standby. Actually, for standbys, that would be a problem with streaming replication, but for logical replication in Postgres, that will also become the problem, right? If you're testing new upgrades, if you're testing new versions, if you're planning for upgrade, it's quite typical that you have some slaves that are just up there and running and replicating to verify that the replication works correctly and whatnot. You just don't want to upgrade, upgrade your master just by accident by picking incorrect slave, just like from 5.7 to 8.0, for example, while you are just evaluating 8.0 at the given moment. Also, sometimes, there are hardware differences between the master and some of the slave hosts. Maybe this given slave doesn't have to be as performant or whatnot. Maybe some slaves are used for some particular tasks like backups or add some ad hoc queries or reporting queries. Then most likely you don't want to fail over to the slave also. So you should just use the white and black list just to make sure that the failover will happen only on the list of hosts that are okay to fail over to. So so when you are executing the failover, it's also important that you use the standard procedures. So for MySQL, that's typically read-only or and super read-only. If read-only is disabled, so if it's set to 0, that's the master. If it's set to 1, then that's the slave. And this is quite common language that is used by different products on the market, and so it's good to stick to this pattern. Also, pre and post failover actions. So automated failover process can be especially if you are using like external tool, right? Sometimes can be augmented by the use of the pre and post failover actions. So what I mean here is that you can define some hooks. I mean, there are some hooks defined in the software that allow you to execute some additional code, programs, whatever, at the given the stage of the failover process. So, for example, pre-failover. So I just detected that the master has failed. I'm yet to perform a failover, but maybe user want to run some scripts and take some actions, right? When failover executed, when it succeeded, maybe I want to execute something. When the failover failed, maybe I want to execute something else. So it allows you to to build some more complex logic around the failover. So if you want to perform some action when the master failed, then yeah, you can do it. As I said, like if you want to reconfigure your master reconfigure some application, when new master was promoted, so when the failover executed correctly, then again you can run some scripts at the given time. So it's just a way to integrate better with your setup, with your environment. And as I said, most of the tools that are popular on the market that support failover handling, like MAJ Orchestrator or ClusterControl, and they do handle pre and post failover actions. So this is quite, I would say, this is quite popular mechanism to use. Okay, so now I'm going to talk a little bit about the orchestrating failover across the whole HiveBT stack. So I'll talk how the failover is performed and how the whole other parts of the HiveBT stack will work together. But before that, I'll hand over to JJ for the second pool.
Great, yeah. Thanks, Christoph. Right, so just before we dive into the topic, we wanted to ask all of you what tools or systems you currently use yourselves to manage replication failover. Some of the options here are Orchestrator or MHA, ClusterControl, but maybe you have your own tools or processes that you apply for this, or some other way of managing replication failover. It'd be great to get your feedback here. And I'll use these few seconds also to remind you that you can, of course, ask us questions at any moment by using the question section of your control panel. But for now, I'll let this run for a few moments to give everyone the chance to participate. And I'll share the results, of course, just when everyone is finished here. Thanks for your participation. Great, thank you. I'll close this now and share the results. Okay, so it's an interesting outcome. It seems that the vast majority of you use your own tools or processes, which maybe is not that surprising. And then you're using other tools or other ways to manage replication failover. Any reactions to that, Christoph?
Yeah, I mean, I agree. It's not that it is not that unexpected to see that people are building their own tool chains to handle this. I would definitely like to know what are the other options. I mean, are you performing like manual failover maybe, or is there some other ways that you do it? So if you could, I mean, if you could just comment on that in the questions box, that would be really great, because I personally, I would love to hear what people are using for this.
Great. Thanks, Christoph, and thanks everyone for participating. And I'll hand back over to you now.
Okay, thanks, JJ. So first of all, what we have to keep in mind is that the database does not exist in vacuum, right? So we have like a database tier, but we also be surrounded by other services to create like a highly available environment. Proxies, they need a way to distinguish between the master and slaves, right? So if we are building proxies, so the proxies are application is passing to proxy, and the proxies are distributing the queries across the databases, and they need to know whether it is a master or slave and how it works. Where to direct given particular queries. So in PostgreSQL streaming replication, typically the marker would be like a existence of recovery conf file, which kind of points that this is a standby server. In MySQL, that could be, for example, as I mentioned like a moment ago, the value of read-only and super read-only. So and this is typically the way how you picked up, like whether that's master or slave, active or standby. So if you happen to perform the the failover on using your own scripts or even using the manual process, you just have to make sure that you manage the variables correctly, right? So, and this is because even if you don't really use them later on, first of all, it's just good practice to have a slave set as a read-only and super read-only, just to minimize the chance that the errant transaction will show up. But also, you never know when you switch to some, or you implement some tool that introduces to your environment a tool that actually uses those variables to differentiate between the master and slave. So it's good to have it like upfront. So also, if you perform a change, you should just, especially if you're talking here about the switch over, right? But also for failover, you just you want to make the changes at a given moment. Like if you don't want to send the traffic to your new master, so you don't want to change the read-only there unless everything is up and is ready to, the slaves are slaving off it and whatnot. So you want to make changes at a given moment. And that's like two screenshots about how the proxies can see the cluster. So here it's from ClusterControl. And here you can see we have like a PostgreSQL cluster, one master, two slaves, AJ proxy. We can see that one master is up and running. This is like the read-write backend, and two remaining tools are down. If this would go down, then one of those will be promoted. And for read-only access, all of the servers are available because both master and standbys are available. And here we have MySQL replication cluster with ProxySQL. So as you can see, we have the ProxySQLs, and you can see it's also like one host group with writer, and that's the master, and those just the same story. How things work in behind the scenes is slightly different, but the idea is the same. Those tools check the read-only value, and then they mark given server as. For MySQL, they check the read-only value. For PostgreSQL, the AJ proxy, there's a script which checks the value of, whether there's a recovery conf or not, among others. So if you happen to use ClusterControl, then all of the load balancers deployed by ClusterControl follow those rules. So you can, and that's why we kind of like use this to ensure that everything is defined correctly, and ClusterControl is implement. When we perform failover through ClusterControl, we just make sure that it works like that. So the main difference is that for MySQL, we have this read-only configured in the MyCNF by default. So if you restart your master, then it will start as a read-only. And this is actually expected because, you know, when you're doing switchover, so if everything is graceful, you can connect to the master and then just demote it through setting read only equal to 1, and then wait for the proxies to catch up on that, and then, well, just perform the switch. With failover, well, that's not possible because, well, you cannot do this obviously when the master is down. So that's why this read only equal to 1 is configured by default. So if this is the case that just master was restarted, like the MySQL daemon was killed, and once it would start, it should, you know, it will get the read only equal to 1, which makes it kind of safe for us. The thing is that it will not really help if we are talking about the network problems, but I'll, you know, I will just talk about it basically in a moment. So, so some difficult problems that are kind of tied to the replication. So first of all, like, and this will be all about the network, because the network is typically the biggest source of issues in terms of the replication, and it's definitely the issues with the network are definitely the most dangerous ones. It is because if you just kill the master, as I said earlier, you can restart it. You know, you can try to start it back, and then this might work just fine. Or worst case scenario, as you saw in MySQL, this is just, you just set it up with default read-only setting, and then you will just, worst case scenario, will end up with the read-only host, which is just, it's not a problem at all, like standalone read-only server. But with networks, this is a problem. So first of all, networks can be unstable. That's pretty normal, pretty expected. So, and while the replication itself, I mean, it's robust enough just to, you know, to work in this kind of environment. I mean, TCP protocol is pretty much like designed for this kind of issue. The problem are with the availability and about the health checks, right? So with the health checks, I mean, you do some checks, right? You have like the monitoring software, which does some checks. I'll try to access the servers and then take some actions based on the state of the servers. You just don't want to, you know, take any actions based on a single check, right? That's pretty much obvious, but still, you may see some setups which just do just like that. You want to wait a little bit just to make sure it's not like transient problem and it's not like flapping network connection. Also, again, I'm reiterating, make sure you don't take any actions based on just a single point, like a single host point of view, like the standpoint. So it's not like you, okay, I do not see the master, therefore the master is down. No, you need to check from multiple places. And generally speaking, you want to try to expect the network problems will be there and try to figure out what's going on before you take an action. With network problems, we have also like a network split. So with replication setups, with MySQL and PostgreSQL, one of the biggest issues is lack of the cluster awareness, lack of like a quorum support. So basically, the replication clusters, they do not understand that they are like working together, and they are not aware of, you know, one slave is not aware of the other slave, and basically this leads to the fact that, you know, replication clusters are pretty prone to the network split issues, and especially if we are talking about external tools which are performing like automated failover and which check some values, and like, for example, read only, but also for Postgres, like they check for this recovery conf, whether it exists or not. This makes things even more problematic to handle. And there's no easy standard way to avoid this problem. So there are some things that you can do, but that's just about it. So the network split, as you can see on the here on this picture on the right, what happens is that like I have my master, two slaves, some proxy server, whatnot, and basically at some point master is cut off from the rest of the servers, right? So the proxy cannot send the writes there, slaves cannot get the replication data, but the server is still up and running. It just cannot connect to the rest of the replication cluster. So basically, this is the definition, right? The network split happens when there's lack of connectivity between one part of the cluster and the other part. So in our case, for example, the master cannot reach slaves and slaves cannot reach the master. And here are the problems, right? First of all, master is unavailable, right? Because in our case, the proxy couldn't reach the master. So cluster cannot handle writes. So failover should be performed in order to restore the cluster stability, right? Because we want those writes to go through. So we need to promote one of the slaves. The thing is that the master is still running. It's just not reachable, but it's there, it's running. It has read only equal to 0, and you cannot really do much about it. Because you cannot reach it, right? So you cannot change this value. It will not be restarted because right? Because why? Because it's still up and running. So in this case, this topology detection logic will not be enough, right? So once the networks converge, the two writable nodes will show up, and that will be the same with Postgres. You have one active server, two standbys. You just promote one standby to active. You just join it, and then you have like two active servers. So this is the same problem, and the thing is that there is hard to tell. I mean, hard to avoid this kind of situation, and you can try to. You maybe there are some options. I'll talk about it in a moment. Some of the options, but generally speaking, if you cannot make sure that the old master is down or you won't get the traffic, well, the split brain is imminent. And the split brain, what it means is that you have like two nodes which are taking the traffic, the write traffic, and basically as a result the data set drifts apart. So once this happens, there's no easy way. The only way to actually recover from this condition is, first of all, kill one of them, like typically the old master, ASAP, as soon as you can do that. Keep the fingers crossed that not that many transactions were written to it, and then basically you have to most likely manually converge the data sets. So whatever you do, make sure that whatever you do, make sure that your solution will work, and make sure that you test it, and you can beat GitHub into it, because if you have heard, maybe GitHub had quite a serious problem quite recently. What happened is that there was a network split basically between their primary and DR data center, and they switched the traffic to the DR. Of course, some writes hit the old data center, the primary one, so data was not really converged, but they were okay with that. They said that they can easily just take all of those writes to just like a couple of seconds of writes, and they can take it and then work with the customers on a one-to-one basis just to converge this. So that wasn't the problem. The problem was that once they switched to the disaster recovery facility, this facility couldn't handle the traffic, and they had to go back, and that was basically the reason of the whole downtime, because then those additional writes were become a serious problem, and they couldn't just easily switch back. So however you do it, like if you have like active standby data centers, move things around, make sure that you actually test it at some point, then you can actually handle the situation. And here we have, like the story in three pictures. Like, we have master, slave, proxy, network split. So basically, new master was promoted, writes are hitting to the new master, reads are hitting to the slave, replication is going, that's everything fine. But then the network converges and proxy just detects two masters. And that's pretty much that situation. How to avoid those issues? So there are ways that you can reduce the probability of this, or that that will be affected, reduce the impact. But well, it's not always possible to do to cover like all the bases. So first of all, collect as much data as you can before the action is taken. Again, I'm repeating myself. So use the multiple nodes just as to figure out the topology. Try to implement the StoneIt protocol. Like, try to make sure that that do whatever you can to kill the old master, and so it will not show up. Maybe maybe the network is down, but maybe you still have some sort of like separate network, like or that you can use to get and use some sort of like lights out solution, like integrated lights out, for example, just to shut down the server physically. Or maybe you have like access to you still have access to to manageable power plugs, so you can just physically just shut down the power to a given system. Maybe you can write some sort of like kill scripts that just go to the, use the cloud's API or command line just to kill the instance. You can also try to modify the proxies. Like, if you detect that the one network split happened, so just evict the entries about the old master from the proxy configuration whatsoever, so that it does not know about it like anything. The thing is that neither of those will be like 100% bulletproof, and that's the problem. So you kind of like have to expect that some issues may happen at some point. So because when there are network problems, then well, you just cannot know. You just don't know what will work and what will not work. You can remove the you can have a script to remove the things configuration from the proxy, but maybe you have multiple proxies and maybe you won't be able to reach all of them, right? Because of these network issues. Maybe you cannot really reach your servers on which you have scripts that you will use to execute take some actions. So there are some ways that you can try to avoid the the networks. I mean the split brain scenario, but it's not always clear that it's not just like 100% bulletproof solutions, unfortunately. And I would like to give you a quick demo of how things look like in ClusterControl when it comes to the failover. So, first of all, I have two clusters, MySQL replication and PostgreSQL replication clusters. As you can see, master to slaves in both of the cases. I have PostgreSQL on my replication, MySQL replication. I have AJ proxy on my Postgres. Let's start with Postgres maybe. So as you can see, I have my master. I have some AJ proxies. On my AJ proxy, I see that master is up and running, which is expected. I also have some keep alive D servers, which has the virtual IP assigned to one of the AJ proxies. So basically, application connects through virtual IP. It reaches the AJ proxy, and then it reaches based on the port either master or all of the servers. ClusterControl has the auto recovery. So if you would like to perform like the assisted, if you don't want ClusterControl to perform automatic recovery, you can disable this stuff and those options here. And then what you could do basically is just go to your slave and then perform promote slave action. So you can investigate what happened and then take some action. But if you still want to keep the automated failover, then ClusterControl can do it for you. So my master is 100.104. So I'm on the correct server. So PostgreSQL is up and running. So I'm going to trigger the failover. So soon the Azure proxy should detect this. ClusterControl should detect that master failed. Azure proxy should detect that something went wrong, and the action should be taken. So as you can see, the master was detected as failed, and the AG proxy also detected the server is unavailable. So right now, the ClusterControl will perform the failover. So if your application is just like connecting to the database cluster through the AG proxy, at this moment it won't be able to send writes, right? The failover happened already, so the failover is already up and the new master is already up and running. The AG proxy did not catch up on this yet. The slave is being reslaved, so we are running PQ rewind on this, and it will connect. And this should just okay. At some point, this just should keep up. So as you can see, the master was detected as up, and as soon as the slave will be again up and running, then it will show up also here. The last step that I can do, for example, is I can go to my old master, and for example, I can just set it up and rebuild it. So then it will join the cluster as the new slave. So I won't do that just right now, but I'll switch back to the MySQL application, and it's the same. It's the same setup mostly. So you can see I have keep alive D on top of my PostgreSQL, and I have master to slaves. So my PostgreSQL shows writer as 1001, which is my master. Readers are all of the nodes in the cluster. And the same applies here. If I would like to do the manual change and make sure that ClusterControl won't perform the failover automatically, but because I want to just investigate a little bit, I can disable auto recover and then again go to slave and rebuild promote slave. But if I want to just go ahead and let's say go ahead and perform the failover, what I can do is just, in case there will be problems, I can just again force the failover. So MySQL is running, allow -9 MySQL D, MySQL D. Just kill it a couple of times so that will just stay down. And again, as you can see, failover already started. So ClusterControl put the nodes in the maintenance mode. So as you can see right now, the PostgreSQL did not detect like there are no servers in this host group. It will catch up on this in a moment for host group. So this actually the old master is marked as online. This is because I don't have any traffic and here, and it's because the PostgreSQL typically relies on the traffic to detect that the node is up, node is down or up. So it will show up as a down. This old master will show up as a down here at some point, but it will take a longer while because normally it will happen at the first query that he did, but I don't have any queries right now. But as you can see, the failover has been performed, and again, my old master is. I can take some actions. I can rebuild it. I can, first of all, I can investigate it here, right? So if I go here, it's also notice shutdown by user. marker, which means that ClusterControl will not attempt to revive the server. This is expected. I don't want it to show up. Right? So so that's basically it. When it comes to how the ClusterControl can easily perform the failovers for both PostgreSQL and MySQL setups. We will have a Q&A session later on, but I would like to hand over to JJ, I think, for the last poll of 2 days.
Yeah, thanks, Christoph, and thanks for the demo. Yeah, we wanted to ask you one final question for today, if you don't mind, and that's around whether you currently automate the failover process yourself in-house. Whether you are doing so and it's been working quite well, or maybe you are automating the failover, but seeing some issues, or you're not automating but looking into it, or maybe it's just too complex. You've been thinking so far, or you've got some other, a different response to the question. It'd be great to get your feedback here, and I'll let this run for a few seconds, and we'll share the results then. Thanks for your participation in this last poll for today. I'll just close this now and share the results. Okay, so first of all, it's a pretty clear outcome. And second, it's also an interesting outcome. So it seems that none of you are currently automating the failover process, but that's maybe not too surprising because most of you were also managing the failover process manually. So maybe that explains it. But that's interesting to see, and hopefully, you've seen some good, tips today on why to automate and how to automate. Since you seem to be looking into doing this, which is great. So thanks for your feedback on that. I'll just hide this again, and just to point you to this slide, because of course we do. We do want to also have people use our commercial features. So we have an end-of-year promotion for ClusterControl where you can avail of 3 free months if you sign by the 20th of this month. So you've got another 9 days to sign up for ClusterControl, and we'll give you 3 months free on top of an annual contract. That represents roughly 25% in savings. So if you're not using ClusterControl commercially yet, and you want to try it out, first of all, I encourage you to do so. And second, do contact us, to find out more about this promotion. And just on the next slide, Christoph, we just wanted to point you to some related resources to the failover topic. We've written a number of blogs on it, and you can also, of course, you can find my contact details here again, jj@7nines.com. So feel free to email us here if you have any questions. And I see there's one question here. Thank you for asking it. It's the question is on whether ClusterControl can be used under the software network RAID configurations, such as Cluster FSS, DRBD, or Ceph. Christoph?
I mean, the question is whether you mean whether you mean the ClusterControl as itself, or, I mean, generally speaking, we don't really care about the underlying file systems. Would DRBD like directly? It's not supported, so this is not. We will not perform like the failover and promotion of this standby DRBD server. Other than that, as long as this is like regular MySQL replication, then no matter what what kind of file system is there, it will just work.
Great, thanks, Christoph. I hope that answers the question. If you have a follow-up question on that, feel free to ask it by using the question section of your control panel. And we've got another question here on when you see old relay logs removed after the failover, do you have any suggestions, Christoph, on what the reason could be for that?
Yeah, I mean, typically, typically the reason for that would be that when you change the master, the relay logs are removed automatically when you run the change master command. I mean, I believe there is a way to actually change this behavior, but to be honest, I don't really have the answer from the top of my head. So if you could just drop us email, then that would be nice. So we can check that for you. I think there's some sort of MySQL configuration variable that just keeps the old relay logs. But yeah, I don't remember from the top of my head.
Great. Great, thanks. Thanks, Christoph. And there's a follow-up question here actually from Madhu Sudan, and the question is whether there are any future plans for multi-master replication in ClusterControl.
Okay, so I mean, I think it would be also helpful if you could share what kind of database technology you are talking about. I mean, for generally speaking, if we are talking about like a regular replication, we don't really like to. I mean, ClusterControl can be configured to support master application, but then the automated failover would have to be disabled. We don't really like this idea of having multi-master replication like for MySQL. For MySQL, we support Galera cluster, which is much better option to actually handle the multi-master topologies, because that's for what Galera was designed for, with all of the quorum support and whatnot. I don't know about PostgreSQL, to be honest. I think the development team was looking into some sort of like multi-master solutions, but I don't know any details, so I can't really comment on Postgres in this case.
Great. Thanks, Christoph. Madhu Sudan, if you have, if you can let us know what databases you work with, then we could give you a more specific answer. But thanks for the question, of course. And I don't see any other questions just now. Yeah, so just a reminder, that the session was recorded and we'll be making the replay available to you in just a couple of days, and you'll be able to go through the slides again and watch the content in your own time if you wish to do so. And this was our last webinar for 2018. So thanks for participating and for your participation throughout the year. We'll be back probably towards the end of January with our next webinar, so we'll announce that as soon as possible. But until then, thanks first of all, Christoph, for the presentation today and for the demo. Thanks to everyone for your participation. If you have any follow-up questions, feel free to email me at jj879.com and we'll follow up on your questions, of course. But for now, have a good rest of the day, a good week. And if we don't talk before the end of the year, then I already wish you a good new year. And we'll talk to you at the latest next year in January. Thank you and take care for now. Bye-bye.